Okay, so another video here. Today it's going to be on Article 422, which is appliances. Okay, before we start the video, we'll start out with a joke. So, having grown up in a small town in Alabama, my buddy Steve comes home from California and just can't stop talking about how amazing this place is. He says, the malls are huge, the restaurants are fantastic, and I even went to a topless bar. Which my mom then said, what happens if it rains? Get it? Topless bar rains. Okay, that's a joke for today. Alright, so go ahead and open your code books up to Article 422. Okay, Article 422, appliances. Okay, so the scope of this article says, the article covers electrical appliance used in any occupancy. Alright, now we're going to focus like normal on things that are going to pertain more to us, especially in the residential type setting, which is what this semester is about. So follow me along as we kind of jump through the articles and hit the main topics. Remember, you were supposed to read this, so hopefully you did. Alright, so we're going to start with Article 422.5 GFCI protection. Article 422.5A says, general appliances identified in 422.5A through A1 through A7 rated 150 volts or less to ground, 60 amperes or less, single or three-phase shall provide with Class A GFCI protection for personnel. Multiple Class A GFCI protected devices shall be permitted but shall not be required. Okay, so the first thing is when it says multiple GFCI devices shall be permitted but not required, what it's saying is if you have, let's say, a GFCI in the cord of your appliance, then you don't also have to have that receptacle GFCI protected. Does that make sense? Okay. And then in these locations, the following locations, if you read number 1, automotive vacuum machines, 2, drinking water coolers and bottle fill stations, 3, cord and plug connected high pressure spray washing machines, 4, tire inflation machines, 5, vending machines, 6, sump pumps, 7, dishwashers. Okay. So what is the key factor with all those as far as why we need GFCI protection? Water, right? All those things are going to have to do with water, have water around them. And again, we know the GFCI protection, ground fault circuit interrupter, it's for ground faults. And if you have water, the chances of a ground fault are more likely. That's why we're required to have that. Okay? Now if you turn the page and go to B, it says your type and location. Number 1, within the branch circuit overcurrent device, so our breaker, right? A device or outlet within the supply circuit, so if your receptacle is a GFCI, and then integral part of the attachment plug, okay? Number 4, within the supply cord not more than 12 inches from the attachment plug. So if our appliance has a GFCI protection inside the supply cord itself, then that'll count for us, but it's got to be within 12 inches of the plug. Now, why within 12 inches? Because we want to have that protection as close as possible in case something would happen to the cord itself. And then, of course, factory installed in the appliance, which that takes care of the appliance. Now, let's go ahead and jump to 422.10 branch circuits. If we read under A, individual branch circuits, the ampacities of branch circuit conductors shall not be less than the marking rating of the appliance, or the marking rating of the appliance having combined loads. Okay, so basically, we can't have an appliance that is rated at 20 or let's say 17 amps and put it on a 15 amp circuit, which is kind of a duh thing, but they've got to put it there so that you know you don't do it, because some people may try to do that. Now, if we go down below that, it says ampacities of branch circuits for motor appliances not having a marked rating shall be in accordance with Part 2 of Article 430. 430, of course, is motors, right? And so there's a lot of things in appliances, a lot of appliances that have motors, so some of those things with appliances, we have to actually go to look at motors as far as for the protection. Next paragraph, branch circuit rating for an appliance that has continuous load other than motor operated appliances shall not be less than 125% of the marked rating, or not less than 100% of the marked rating if the branch circuit device and its assembly are listed for continuous loading at 100% of its rating. Okay, and there's again 125%. What is what I call opposite of that? 80, right? Which we talked about, that we only want to fill our circuits up to 80% if we have a known load, right? So in a 20 amp circuit, we only want to go to 16. Or if the appliance is rated at 16 amps, then we go to the 20 amp overcurrent protection. Let's go ahead and jump down to 422.11 overcurrent protection. Let's go to A. It says branch circuit overcurrent protection. Branch circuits shall be protected in accordance with 240.4, which we know 240.4 is, of course, overcurrent protection itself. It says if a protective device rating is marked on an appliance, the branch circuit overcurrent device rating shall not exceed the protective device rating marked on the appliance. Okay, so some of your appliances will say, I need an overcurrent protection device, a breaker, that is this size. We cannot go above that, right? If it says it needs to be 15 amps, we can't say, well, we're gonna up this and go to 20. You know, a lot of times we can. There are certain times we can do that, but when it comes to the marking, if it's marked on the appliance, that's the overcurrent protection. That's all you can do. Okay. Let's look at B. Household type appliances with surface heating elements. Okay, so and of course surface heating elements would be like, let's say, a range. It says household type appliances, surface heating elements have a maximum demand of more than 60 amps, calculating according to table 2.55, which, or 220.55, which 220 is .55 is your range calculation page. Shall have their power supply subdivided in 2 or more circuits of each of which are provided with overcurrent protection and not over 50 amps. The big thing that we want to make sure that that we're aware of when it comes to ranges, especially in the residential setting, we're not going to go over 50 amps, right? And it's going to take a big range. In a residential setting, you're not really going to have any that are over that, unless you have multiple range countertop cooking units and wall-mounted ovens on the same circuit. Then we can have the problem. Okay, but we'll talk about more of that when we get to that point. Let's jump down to E, and I'm sorry, I know we're going fast, but there's a lot to cover, and I want to cover as quickly as possible for you, so the video is not too long. E, single non-motor operated appliances. If branch circuit supplies a single non-motor operated appliance, the rating of overcurrent protection shall comply with the following. Of course, number one, like we talked about before, it cannot exceed that marked on the appliance. Number two, not exceed 20 amps if the overcurrent protection rating is not marked and the appliance is rated 13.3 amps or less. Okay, not to exceed 150% of the appliance rated current. If the overcurrent protection rating is not marked, the appliance is rated over 13.3 amps. Where 150% of the appliance does not correspond to a standard overcurrent protection or amperage rating, next higher standard rating shall be used. And we see that a lot, right? We can go to the next higher standard amperage rating. But the biggest thing is also we need to make sure that whatever we have our branch circuit overcurrent protection rating at, our conductors can handle it, right? Let's go to F. Number one, electric heating appliances. Electric heating appliances employing resistance type heating elements rated more than 48 amperes, other than household appliances, surface heating elements covered in 422.11b, and commercial type heating appliances, 422.11d, shall have the heating elements subdivided. Each subdivided load shall not exceed 48 amps, and each subdivided load shall not be protected more than 60 amps, by more than 60 amps. Okay, and again, it's not quite as much residential, but we need to subdivide that load, right? If it's going to be that high. The next, let's jump to 422.12, central heating equipment. Central heating equipment other than fixed electric space heating equipment shall be supplied by an individual branch circuit, meaning that's the only thing on the circuit, right? Now, if we read the exceptions, though, underneath that, it says the auxiliary equipment such as a pump valve, humidifier, or electrostatic air cleaner directly associated with the heating equipment shall be permitted to be connected on the same branch circuit. Exception number 2, permanently connected air conditioning equipment shall be permitted to be connected to the same branch circuit. So if it's something as part of that heater, the heater itself that helps it run or modifies how it runs, it can be on the same circuit. Other than that, your heater has to be on its own circuit. You know, which kind of makes sense because it draws a lot of power. And in reality, if it's electric heater, it's going to end up having 2 circuits feeding in one for your regular power and one for high fire. Okay. Now, like in our heater downstairs, we have a humidifier on it. And so that humidifier is actually fed by the heater, and that's okay. 422.13, storage type water heaters. It says a branch circuit, overcurrent device, and conductors for fixed storage type water heaters that have a capacity of 120 gallons or less shall be sized not smaller than 125% of the rating of the water heater. Okay, and so the water heater itself should have, unless it's an older one, should have the actual rating for the overcurrent protection on it. 422.15, central vacuum outlet assemblies. A says a listed central vacuum outlet assembly shall be permitted to be connected to a branch circuit in accordance with 210.23a. B says the ampacity of the connecting conductor shall not be less than the ampacity of the branch circuit conductors to which they are connected, which obviously makes sense. Let's see. C, accessible non-current carrying metal parts of the central vacuum outlet assembly likely to become energized shall be connected to an equipment grounding conductor in accordance with 250.110. Incidental metal parts such as screws, rivets, or rivets installed into or insulating material shall not be considered likely to become energized. Okay, so again, central vacuum assemblies. Some of you guys have seen those possibly. They have the pipes, the vacuum pipes that are in the wall, and they go down to one central. It's like a central vacuum assembly that does all the suction, and then you just hook a hose up and vacuum around the room, right? Which means you ain't gonna have to push a vacuum around. Don't have to worry about cords, stuff like that. So they're really nice. Only problem with that is if stuff gets clogged, it makes it very difficult. And so that's one of the things you gotta think about those, but overall they're still really nice because you use one hose and move it around. Okay, just gotta make sure everything, like I said in there, everything that's non-current carrying metal part is grounded. Okay, all right, now, okay, really quick, I'm gonna move this over here. That way I can see while I'm doing this. And sorry also if my head is kind of, when I move up here to talk, when I move around to talk, my head kind of disappears. That's just, I move around. Okay, so next, let's talk about flexible cords, right? So it's Article 422.16, flexible cords. It says flexible cords shall be permitted as follows. To connect appliances to facilitate their frequent interchange or to prevent transmission of noise, vibration, facilitate removal or disconnection of appliances that are fastened in place. Basically, if it's going to have to come out or have to get moved, we're allowed to use flexible cords. Obviously, if it's an appliance that's fixed in place where it's not going to be moving a lot, it's going to be better if we don't have a flexible cord, right? That's just because that's one less thing we have to worry about, one less connection. But for a lot of times, like with a dishwasher and garbage disposal and stuff like that, we're going to use them, right? B. So B1, electric operated sink in-sink disposers. Okay, so it says we can use flexible cords for these. Number 1, the length of the cord should not be less than 18 inches and not over 36 inches. Receptacles shall be located to protect against physical damage onto the flexible cord. Receptacles shall be accessible, and then the flexible cord shall have an equipment grounding conductor and be terminated within the grounding type attachment plug. Okay, so 18 inches to 36 inches. Why? Number 1, 18 inches, the minimum, because it has to be able to reach the attachment plug, right? And then 36 inches because we want to keep the receptacle that it's going to plug into close, right? We don't want to be plugging it in somewhere else, right? Because the receptacle it's going to plug into needs to be GSCI protected, so it's got to be close. Of course, the physical damage thing and accessible. And with the garbage disposal, we put the receptacle. When we use the receptacle, it's underneath the sink, right? And it's going to be GSCI protected because it has to be with a 6-foot sphere of that sink. Okay. Moving on. Turn the page here. 2 here is built-in dishwasher and trash compactors. They can be cord and plug connected also. Number 1, for a trash compactor, length of the cord 3 feet to 4 feet. Number 2, dishwasher 3 feet to 6.5 feet. Now, one of the reasons we're allowed to have a little bit more on the dishwasher is because it's got to go from the dishwasher spot all the way over, normally underneath the sink. If we are using a dishwasher, we can or a cord for our dishwasher, excuse me, we can no longer have the plug behind the dishwasher. That's the way it used to be. Now it has to be outside of the dishwasher space. Let's see. Number 5 there says the receptacle for the built-in dishwasher shall be located in the space adjacent to, just like I was saying, the space occupied by the dishwasher, where the flux cord passes through an opening. It shall be protected against damage by bushing, groundment, or other approved means. It shall be accessible and it has to have equipment grounding conductor, which almost everything has to have equipment grounding conductor. There's a few things that we've talked about, and we'll talk about that don't have to have that, and that is a double insulated. Usually it's tools, but they do double insulate like dishwashers and stuff like that, or garbage disposals, excuse me. But when it's something around water, I'm going to have it ground regardless. Okay. 3. Wall-mounted ovens, cabin-mounted cooking units. It says wall-mounted ovens, cabin-mounted cooking units, complete with provisions for mounting and for making electrical connections, shall be permitted to be permanently connected or cord and plug connected with flexible cord as identified as suitable for the purpose in the installation instructions of the appliance manufacturer. Excuse me. Several connector or plug receptacle combination in the supply line or even an oven cooking unit shall be identified for the temperature of the space which is located. Okay, wall-mounted oven, cabin-mounted cooking units. A lot of times, it's back and forth. They're going to be direct connected. When it comes to a range, however, that's most of the time is going to be cord and plug connected. Right, we're going to talk about that here in a minute. Number 4, range hoods and microwave oven range hood combinations. Excuse me. So a lot of times now, obviously, we used to have the range hoods which just had the exhaust fan above it and suck the gases out, right? But now, more and more often, that range hood is actually the microwave also. So it filters that air coming through, and your microwave's right there, which is really nice. So obviously, when you're cooking, have it there, take your food out, and it's right there to work with. Okay. Now, if we read down, it says number 1 on those, the length of the cord is not less than 18, not greater than 4 feet. Obviously, we got to have enough length to get it to the plug, but not too much length where we can plug it into another one, because we're going to find out here shortly that the range hood has to be on a dedicated circuit. Okay. 2. Receptacles are located to protect against physical damage to the flexible cord, and that is done by putting the receptacle itself inside the cabinet above it. And then number 3, the receptacle is supplied by an individual branch circuit. Okay, so that's the one I was getting at. What is an individual branch circuit? It's a branch circuit that only one thing is on, meaning that that receptacle that we're going to power that by is it's by itself on one branch circuit. And what we're going to do then is make a single receptacle in that spot so that only that can be plugged in. We don't want to have anything else plugged into it, right? And so we just use a single receptacle. Receptacle should be accessible, which it is, up above the cabinet above it. It's up inside there, so it's accessible. And the grounding conductor. All right, let's jump to 422.18. Support of ceiling suspended paddle fans. Can't say that word. Ceiling suspended paddle fans shall be supported independently of an outlet box or by one of the following. Listed outlet box or listed outlet box system identified for use and installed in accordance with 314.27c, and then a listed outlet box system and locking support. The main thing is, and if you look at your picture in your code book in exception 402.3, it shows you kind of a ceiling fan box. Now, I myself don't like those. I prefer, because those have the little wings on the side, I prefer the ones where if this is your stud space, or your ceiling joist, put a 2x6 in there, and then you mount the ceiling fan box like this, and then your fan will mount to this here, right? And the reason I like that, because we're going to have, this is going to be screwed in here with your strength, and then this will be screwed up with big lag screws into this 2x6 that's going across that stud space, and then it's not going to go anywhere. The one they show in the book has stud space like this, it has the box like this, and then it has wings like that. And the reason I don't like that is because your supports are all in there on the one ceiling joist, and then if that fan's going to lean like this, it's going to want to keep pulling off that, right? Where here, if you got it up against here, it can't move either way. That make sense? Okay. Okay, now, excuse me, 422.20, outlet box to be covered. In complete installations, each outlet box shall be provided with a cover unless covered by means of the ceiling, suspended paddle fan, canopy, right? And when it comes to the paddle fan, the canopy is going, we're not going to have just a regular cover, we're actually going to have a canopy. So, we have our drywall here, and then our box like this. And then of course you have your mount. You're going to have a canopy that's going to cover all that. Okay, and then the fan of course is going to be below that. And I'm a terrible artist, I'm sorry. Okay. Part 3, disconnecting means, 422.30. In general, it says the means shall be provided to simultaneously disconnect each appliance from all ungrounded conductors in accordance with the following sections. Part 3. If an appliance supplies more than one branch circuit feeder, these disconnecting means shall be grouped and identified as being multiple disconnecting means for the appliance. Each disconnecting means shall simultaneously disconnect all the ungrounded conductors, right? We have to be able to disconnect these appliances, whether, so if we're going to work on them, remove them, whatever we're going to do, we have to be able to disconnect them, right? So, 422.31, disconnecting of permanently connected. A says, if it's rated on over 300 volt amps, half horse, it says that a branch circuit overcurrent device shall be permitted as a disconnecting means, meaning our breaker, right? So we can use that breaker as a disconnecting means. But the thing is, it has to be within sight, where the switch or circuit breaker is inside of the appliance, or the cable being locked in the open position, right? And there's breaker locks, locks themselves, so you can put them on and put a lock on it, and they're not going to turn back on. Okay, and then B says, appliances rated over 300 volt amps, permanently connected appliance over 300 volt amps, branch circuit switch or circuit breaker shall be permitted to serve disconnecting means, or switch or circuit breaker within sight from the appliance, or cable being locked. Okay, so basically the biggest thing is have it within sight, if we're going to use that breaker. Otherwise, we need to have a totally separate disconnecting means. A lot of times what we're going to end up doing in that case is we'll just use like a toggle switch right by the device, right? And so we can shut it off there. Okay, 422.23, disconnected means cord and plug connected or attachment fitting connected appliances. Several connector or attachment plug attachment fittings and receptacle. Cord and plug connected appliances and accessible several connector or accessible plug or attachment fitting and receptacle combination shall be permitted to serve as disconnecting means. Okay, so what this basically means is if we have a cord and plug, like let's say your washing machine, and you want to work on that, as long as it's cord and plug connected, removal of that plug counts as our disconnecting means, right? Because we're taking the power totally away. And if you go by the 6-foot standards, the very next section where it can be, it's going to be within sight, right? So we know if somebody's going to try to sneak in there and plug it in, we're not going to get shocked, okay? Now, B, it says connection of the rear base of the range. For cord and plug connected household electric ranges, an attachment plug and receptacle connection at the rear of the range, accessible from the front by the door, shall meet the intent of 422.23a, meaning we can use that plug as our disconnect. The big thing here, let me show you. Okay, so this is my range, right? We have our oven, we have our upper controls for the heating elements up top, and then we have our drawer at the bottom. What that's saying is, from this drawer here, that receptacle has to be down in at the height of that drawer, so when we pull that drawer out, we can unplug it, right? If that's the case, that counts our disconnect. If not, if this isn't accessible here, if it's going to be back in line here, we have to actually have a different disconnect to kill power for that. Okay, so make sure that when you're installing these, get that down low. Okay, 422.47 water heater controls. Also order an instantaneous type water heater shall be equipped with temperature limiting means in addition to the control, thermostat, or disconnect all ungrounded conductors. Such means shall comply with both of the following. Installed to sense maximum water temperature, be either trip free or manually reset type. Okay, so this overcurrent protection, it says trip free, manually reset type, or having a replacement element, right? So what does that mean? That means that if it does trip, it has to be manually reset, meaning you have to go and actually reset it, or it has to have the elements actually burn out, right? Which is a pain and a little more expensive, but they both do the same thing. It makes so that it doesn't restart on its own. And why do we want that? Because obviously, if it trips, if it pops, if it burns up the element, we know something's wrong. If it's going to automatically reset, which would be nice at sometimes, we're going to continue to make the problem worse, right? And so and that's why it has to be manual reset. Okay. Let's jump down to 422.50. Cord and plug connected heating or connected pipe heating assemblies. It says cord and plug connected pipe heating assemblies intended to prevent freezing or piping shall be listed. Okay. Why'd they put that in there? Of course, everything's supposed to be listed, right? Well, one of the issues that they have, that why they have to actually put this in there, is because we've had a lot of issues with fires and people kind of making their own things or jerry rigging stuff so that it will keep their pipe. And what they do, what that is for, in case you don't know, people have on their porches or whatever, sometimes they'll have their washer and dryer on a porch that's not heated a lot. And so if this is a porch itself, okay, back here, let's say there's a wash machine, and then they have their plumbing that's coming up like this and then feeds to that washer. Well, it gets cold, sometimes that'll freeze, so what people do then is they will wrap these things up with this heat tape. And what that does is make so that those pipes don't freeze. Right? I actually lived in a place forever ago, and we had to do that. At the end here it says 422.60 is marking, or part 5 I guess is marking. 422.60, 61, and 62. We're not going to really go through these a whole lot, just for the fact that most of the marking stuff that's going to be done here, nameplate and all that stuff, is going to be done at the factory. It's not something that we as electricians are going to do, right? And so you need to just know that those nameplates and those markings are going to be there, whether it's information on your voltage, your frequency, or even your overcurrent protection required for that, right? And that's the easiest thing to do, that's the nicest thing to do, or to have, excuse me, is the overcurrent protection size marked on it. Because then it takes all the thinking and the math out of it, right? Okay, so I hope I didn't go too fast. I tried to go somewhat quick so we can get through a lot of this stuff, but I tried not to go too fast, so hopefully you could understand what I was saying. Okay, so that's it for this video. If there's any questions, make sure you go ahead and in the comment section below, just leave a comment, ask a question. But also, if anybody else is watching this and you have a question on a certain thing, just put it in the comments below and I'll see if I can do a video on that too. And I'm also going to hopefully do some blooper type videos too. My students requested something like that. I think they just want me to shock myself, but I'm not sure. So, but I don't know about doing that, but we'll do some other funny videos here sometime soon. So anyways, that's all I got. Thanks for watching.